Well, they say things go in threes and that. I'm going to have a look at this. The last customer with the Harvard 420M has sent a scrap chassis which he's bought in a batch of stuff, and he's given me this as a freebie, which is really kind of him, because this scrap York 861 has a fascia, and I need a fascia for one we did which didn't have one. But you know what, I can't really scrap this, can I, until I've tested it. Oh, it looks in lovely condition. So it's missing the microphone socket. That's why the fascia's been removed. So, can I see any missing parts or any silliness? Well, I can't see any missing parts, and I can't see any silliness. In fact, that's in better condition than his Harvard 420M. I'll tell you what we'll do, without putting a socket in, and you don't need to pinch them off a scrap chassis anyway, sockets, they're so readily available. We'll power this up, and we'll see if the VCO locks. Because that will tell me whether the synthesizer is running, and if it is, well, it's worth hanging on to. I think we're going to end up putting a request out. Anyone got any case halves for a for a York 861? Can you see what's coming? Because I can. Right, so we need to power it up. Well, we've already got the lead. So it does power up. So we'll put it on channel 20. And I'll just see if the VCO is where I'd expect it to be. Yeah, that's locked. So we'll put a signal in from the signal generator, and we'll see whether the thing's receiving. It's 2779125. I'll put this on the inset picture, then you can see me doing it on the signal generator, on the frequency. Yeah, on the signal generator. I'll get the word right. 79125. I've got a couple of brand new sets from Thunderpole coming up in a few days. I think one of them is the latest T800. Yeah, look, we can see that the set's actually receiving, and that is 3 microvolts, so it's definitely receiving okay. So pause the video and I will put a microphone socket on this. So let's see. I mean, I don't have to use a new one because I've got a plethora of scrap sets here, which are going to give me a nice microphone socket. What's this? So there's 2 types of socket. Here's one, another of which we need a front for. You can see how that's mounted onto its flange. There's 2 types. Some have a screw thread on the back, and some don't have a screw thread on the back. So that first one I looked at, which was Uniden, didn't have a screw thread on the back. We've got a scrap little Falcon. Now Alan sent us a Falcon which we're going to try and get going, but I've got this scrap Falcon which we're going to hopefully use to sort the one Alan kindly sent, which has a phase lock loop problem. So I've been able to recover that off the scrap Falcon, and that should be the right type. So this mounts on the front through there first, and it's the flat to the bottom. So it looks like somebody simply scrapped this radio so they can have the 4-pin mic socket, which I just find bizarre. I'd rather spend 84 pence on a 4-pin mic socket. Right, we're going to have to copy the wiring on this one here. So once again, I'll pause the video. Right, so let's see what we can do. So that's wired. We can now plug the instrument speaker in. And there it is making a noise, and we want our Cybernet mic. We'll select channel 40. No dirty channel selector switch on this one. Check the VCOs around about 4 volts. It's a little bit high. Going to transmit and see if the VCO is about 4 volts. A little bit low. I'm not getting a connection. Back to receive, that'll do me. So we'll see what it's like on channel 1, that's fine, and on transmit, that's fine. So really the receive VCO was slightly out, so that can cause channels to drop out in very hot weather or very cold weather. Alright, Alan's lead doesn't want to stay put. So remembering to go back to channel 20, see what the power's doing. And the answer is 3 watts. We're going to fill a sheet out now. RX VCO low. 4 volts plus 4 volts. Don't know what the date is, let's call it the 23rd. Right, so transmit is doing a good 3 watts. Yep. So on channel 20 it's doing 3 watts. On channel 40 it's doing 2.6 watts. On channel 1 it's doing 2.6 watts. On low power, we'll go back to channel 20. It's doing 100 milliwatts. Back on normal power, current consumption is 905 milliamps. Frequency is, we've already seen that together, but we'll look again. I may as well do that right now. So it's hardly out at all. That'll do. Slightly high. Deviation, for what it's worth on this test set, wallow, 1.5. We'll check that on the test set behind me. So we've got that working. That's not applicable. That's not applicable. That's working. We'll come to the switches and let's see what the meter reads when I key up 3. And let's see what the meter reads on receive when I put S9 on. So for S9 it needs what? 240 microvolts. Good. Right, we'll run through the transmitter and then I think it's tea time. So we'll stay on the 3 watt scale until I can't go any further. It's easier on the 3 watt scale than it is on the 30 watt scale. It's a shame this test set doesn't have a 10 watt scale, but it doesn't. Oh, there we've gained a bit. We'll go back one as well. Alright, we'll go to the 30 watt scale, and now we need to put all these to absolute maximum. For a very quick period. Really need to be able to do this within 30 seconds. You're going to start having smoke come out of it. That's a bit. Not quite ideal. There's wear in the core. Now, some people have said, and it's a valid point, we could use an Allen key, not with it powered up, and not to get the reading, but just to slacken it off. And it's very, very easy to break them with an Allen key. Just check that's right. So we've now got 4.5. So what we need to do is to turn the L4 is it clockwise for 4.4 watts. And there we have it. And then we need to turn this one anti-clockwise. They say for 3.8 watts, but we'll do it for the legal maximum of 4. I'm going to have to do that, and then we'll trim it from there. That's right. So it affects the reading, and I've got it right. So we've got 4 watts on channel 20. So ideally we want it to be within 0.1 of that on channel 1 and 40, in other words at the band extremes. So but channel 40 we've now got 4 watts, and at channel 1 we've now got, hey, 4 watts. I don't know if I can get that. Go to the top of the class and jump off. John Smith used to say at Nottingham Radio when I was there. So current consumption is now 1.18. Not a lot more current though for all that more power. Not that it's going to make much difference to the range, because it doesn't work like that. Let's look where we are on low power now. That's still just as drivelly. So I think it's time to put some service solve switch cleaner on that preset, and hope that, unlike the Harvard 420M we did yesterday, that the track isn't broken on the preset. Note this one's alright. There we go, 400 milliwatts. So we'll come back to deviation. Let's set the meter. So back to normal power. So we just need to adjust them. We just need to adjust that. There's some clumsy English, to 4 watts. So remember, it's only 4 watts into a dummy load. That's how it's set. When we put it on an aerial, it may read 2, it may bang across, but the radio will still be giving 4 watts. It's because it's relative to SWR. So don't think you're banging out if it's banging across, because you're not. Good. Well, there we are. I'll have a quick look at this receive. While I'm on a drum roll, let's plug that back in. Synod meter on. So we'll have a look at the synod. It's really good actually before we start. And make sure I'm in the right range, because I can easily switch these switches to the wrong range. No, it's the right range, alright. 3.6 for 12 dB synod. 0.36 microvolts. For 10 dB, 0.31. For 20 dB, which it does easily, 0.65. Squelch maximum is 30 microvolts. I want it tighter than that. And minimum is 1 microvolt. The meter reads, we've already covered that, 240 microvolts. Right, so see if we can start with the detector. So with 100 microvolts on the signal generator, we'll look at the oscilloscope screen. Maximum recovered audio. Well, that was a bit out. It'd be a bit garlic. What's that, Dalek and the garlic? Right, that's that done. Turn the oscilloscope off, save a few watts, and go over to the synod meter and see if we can get even more out of this excellent receiver. Right, we've got a bit more there. I'll put a bit more signal on to do these IF ones. It's alright. That's alright. Let's go back to the first one. What a cracking set. Pity there's no lids. Right, let's see what we've got. So 12 dB now. Got 0.22. For 10. I don't know, I'm going to change scales. Yeah, 0.25 on the other scale. 0.23. And for 20, 0.4. So we'll just do the squelch. So I could turn the squelch to full on the radio. It's at 10 microvolts now on the test set. Let's put the attenuator on the screen for you on the inset picture. So 30 microvolts, I want it to open at that. No, I don't. I want it to be squelched at that. Open at 100. That's it. That's where I want it. So now we'll just see what we get for our threshold positions. A signal generator to stand by. Turn the squelch down. Set threshold. Switch the radio back. The signal generator back. It's now 1.5 microvolts. I'd have liked it more sensitive than that. It might be my big fat fingers. Let's try another again. Try it again. So that's squelch threshold. Yeah, we can do better. So second time I've got 0.8, which is ideal. So I'm going to leave the figure there, but we did do better than that. So let's see whether this tone switch makes any difference. It does. So we can now tick off all the switches work. That's alright. And the RF meter now reads 4. So behind the scenes I'll just check the deviation, and then we'll just put it on the aerial and we'll do an on the air test with no lids. Okay, so here we are. I've set the deviation using the test set behind me. It was 1.5 hour. Normal one was actually working today. 2.22, 2.5 kilohertz. So set's all done. We need the knobs. We need both the lids. So we've now turned a scrap chassis into a working set. And all we needed was the missing mic socket, which I took off a scrap Falcon. So any of you out there want to sell me a case, you see how this customer of mine has so kindly passed this on to me to give me a front for the set I need a front for. But how could I not try the set? And there was so little wrong with it, and it's such a lovely performer. One on a Roger. Right, well there we have it. York 861 resurrected from a scrap set. So we'll do an on the air test with it naked, just like that. because the set is spot on. Thanks for watching Resurrection of a York 861.